Hello and welcome to section 2.5, or sorry, 2.6. We're going to be proving some more statements today. Here are the answers to 2.5. If you have any questions, make sure you let me know. Whenever you guys see the proofs, make sure that you are attempting all the proofs. It's very, very, very critical for this class. Alright, we're going to, as I mentioned, prove more statements today. We're going to be working with segments and angles today. And we're going to be writing two-column proofs. And I've kind of introduced two-column proofs a little bit throughout the last lesson or so. Proof is a logical argument that shows a statement is true. It's a type of deductive reasoning. And two-column proof is a type of proof with numbered statements and corresponding reasons that show an argument in a logical order. There are different types of proofs. The main type of proof is a two-column proof. We are going to learn about other types throughout the year. So here's an example of a two-column proof, and the reason why I'm choosing this one here is because this is one that we've already seen. So you're going to put your statements on the left, you're going to put the reasons on the right, and you're going to number them so they match up. 1, and then we're going to put 1 over here. Now, we are given that angle 1 is equal to 3. Those two are equal, and we have to show that EBA, and DBC are the same. So that's what we're trying to prove, is those two larger angles are the same. You might say, well, they look the same, so they're the same. No, we're actually going to have to prove that. So EBA equals 2 plus 3. So EBA, this one right here, is equal to 2 plus 3. So if I take 2 and 3, add them together, I get the entire angle. That's our segment addition postulate. And then it says that EBA now equals 1 plus 2. So that's where we did that substitution. We took the 3, and we know that 1 and 3 are the same, so we make that substitution right there for the 3, so the 3 turns into a 1. So that is the substitution property of equality. Okay, then I have 1 plus 2 equals DBC. I'm going to look at my picture over here. 1 plus 2 equals DBC. So DBC, all right, again, if I take 1 and 2, that gives me the entire angle. That is the same thing as above, angle addition postulate. And now I go to say that instead of 1 plus 2 equals DBC, it says EBA equals DBC. So 1 and 2 are right here. And that's EBA. So I can take this and replace this right here with an EBA. So we could do a substitution or a transitive. A lot of times transitive and substitution can sometimes be interchangeable. Not always, but sometimes. Okay, so in the book went with transitive here, and they said, okay, well, if EBA equals 1 plus 2, and 1 plus 2 equals DBC, then EBA equals DBC. So it goes 1 to 2, 2 to 3, so 1 to 3. So that's what they were going with there. But you could also use a substitution as well. And if that's the case where either is acceptable, I will accept either answer. Okay, next up is another segment proof. AC, we're given that AC equals AB plus AB. So this entire segment here is 2 of these basically. We gotta prove that the 2 smaller segments are equal to each other. So AC equals AB plus AB, that's given to us. That's our almost always gonna be our first step. AB plus BC equals AC. So if I take AB and I add it to BC, that gives me AC. So this plus this equals this. That is our segment addition postulate. Okay, now we have AB plus AB equals AB plus BC. So you notice here we have AC and AC. So I could take this here and plug it in for here because they're equal, or you could do transitive. AB plus BC equals AC. AC equals AB plus AB, so AB plus BC equals AB plus AB. So this one either could be transitive or substitution. And finally, last step is AB equals BC. Well, you're going to notice here, this is a new step that we're learning, okay? If there's the same value on both sides, we can subtract AB from both sides, just like in algebra, and that eliminates it. So this would be the subtraction property of equality. We're subtracting the same value on both sides, and that proves our statement that AB equals BC. Theorem is a statement that can be proven. Once you've proven a theorem, you can use it as a reason for other proofs, which is pretty cool. So a lot of what we're going to do is we're going to prove statements, and then we're going to use those proven statements for other proofs. Congruence. This theorem here, you don't have to memorize it as theorem 2.1. You just have to know these vocab words, and they're the same as before. And you're going to notice they're the same for all these: reflexive, symmetric, and transitive. I'm not going to go over these; they're right here. But it's the same as the equality statements. Versions. Okay. So in the previous lesson, we talked about the measure of angle A equals the measure of angle A. It's the same thing. It's just saying angle A is congruent to itself. Okay, so a couple examples. If R is congruent to T and T is congruent to P, then R is congruent to P. That's transitive. This comes up a lot. And you can just write down transitive. That's okay. Q to V, V to Q, symmetric. And NK to BD, BD to NK. Also symmetric. Alright, so there's just a couple examples for you. Alright, one more line proof, I think. Two more actually, okay. Two more proofs. Let's see, if you know that M is the midpoint of AB, prove that AB is 2 times AM, and AM is half of AB. So I have two different proofs. We're going to do this one first, and then from there we can do part B. So M is the midpoint of AB. And that's given. Alright, so if M is the midpoint, we know that AM has to equal MB. Those two have to equal to each other. Okay, so AM equals MB. Definition of a midpoint. Okay, so these two are equal. That gives us some good information. I'm trying to show that AB is twice AM. I don't have anything with AB in it. So what I'm going to do is I'm going to introduce AB. And I know that AB is equal to AM plus MB because segment addition. So I introduced AB because I have an AB here, but I don't have an AB in my 2-column proof, which I should number actually if I'm being really correct. But I don't do this very often. I forget to. So, okay, segment addition. Now I'm trying to get AB to be twice AM. Well, I have one AM already, but I have an MB instead of another AM. So this here is going to come right there, and that is a substitution. AB equals AM plus AM. I'm taking out the MB and I'm replacing with an AM because they're equal. Substitution. All right. And now we're just going to simplify. AB is equal to twice AM. That is just, you can just say simplification. And they might say like addition or something. We're just simplifying. And then we're done. Now if we want to prove the last one, AM equals half of AB. Okay, well I can just divide that by 2. Divide by 2 on both sides. So AM equals half of AB. And that is the division property of equality. We're dividing the same value on both sides. So there you go. I'll save this one for class. This is an interesting one. Unless you want to try it, I'll kind of set it up for you if you guys want to give this a try, but I can go over it in class with you guys. B is the midpoint of AC. So here's AC, and B is in the middle, which makes that equal to that. And C is the midpoint of BD. Okay, so I need to extend that here to D. And C is the midpoint of BD. So that means this is equal to this here. It's a lot of transitive stuff. So we're going to prove that AB equals CD. Involves a lot of transitive stuff. So I'll leave that for you guys if you want to give that a try, and if not, I can go over it in class with you. Alright, here's your assignment. You're always going to see some proofs near the end of the section, so make sure that you're attempting all the proofs and you're asking questions on the proofs if you don't understand them, because that is what a lot of this class is all about. Thank you for tuning in.